This thick pencil line here is the Earth. And I've drawn it straight because we're only talking about not that far a distance. And after all, that's how we see the Earth every day. It's obviously flat and level, observably and measurably flat. So I've drawn it straight. It's level, and this man is standing in a room, and the corners of the room are all square. So the top is also level. It's parallel with this level. These sides are parallel. And then the next room is the plumb room. This is the plumb line hanging down here. And it's the same as this room, but it's got a plumb in it. So the next room is the flush room. In fact, actually it's they're not so much rooms, but it's going to be a big long corridor going down this way. So we've got level roof, level floor, and this man's going to walk along this corridor. So as this man goes along this corridor, the centre of gravity is down this way to begin with. As he goes along, the centre of gravity is going to be this way. And the further he goes along, the more the centre of gravity is going to lean over like this. You know, be more of an angle like this. So as he walks along here, he's going to be on his tippy toes, leaning forward like that. Have you ever seen that happening? Have you ever walked down a tunnel, or have you ever a long corridor or a long... So that doesn't happen, does it? And besides, these partitions, they're all flush and plumb. This one's plumb, that one's plumb. And they're 90 degrees, so the plumb line can't start going like this. This plumb line can't just start going like that as it goes along. Because this is level, and that's 90 degrees, and that's 90 degrees, and that's 90 degrees. And you could measure these first ones, they'd be parallel, these plumb lines would be parallel. And this is flush to it. So no matter how long you build along here, this isn't going to start, plumb line's not going to start going like that. So now, if you can still see, this man now has to come out onto the top of the roof because he's underneath Denver Airport, okay? Now, so he comes out onto the top of the roof, and of course his aeroplane, you can see it, we'll put it in the middle a bit more here. His aeroplane would also have to be up at a level like this. And a wheel underneath there too. Something like Thunderbird 1. Have you ever seen that on Denver Airport? I hope not. So he gets out on his tippy toes, he gets into his airplane, which is also at an angle like this towards the centre of the gravity of the Earth. And now he's going to take off and he's going to do a loop the loop, right? in that direction. When he goes up here, the upwards, whichever way you think it is, so what's it going to change now as it goes around here? That's for you to decide, but upwards is always upwards, so as he's flying along here, upwards is that way. Or if you want to think of it, you can go that way. It's up to you. But he's going to do a loop-a-loop anyway. And he's going to fly around like this, and he's going to come out here. So he's going like this, and he's going up there. He's going around like that. So his head's in this, so his head's top of the aeroplane is there, and he's in the inside of the loop, and his head is here, and he's on the inside of the loop. Now when he gets up here, his head is there, and he's in the inside of the loop. Of course he's in an aeroplane, and again there, his head's here. And we'll do one more. Show you like this. Okay, so he's doing like that to begin with, and he goes around like that. That'd be alright, wouldn't it? Loop the loop like that. Yeah, that's okay, isn't it? No problem. But what if he was to take off from here, and then this, it goes the same way around as this loop, the loop, but this time he's gonna go like that, with, of course, the aeroplane tail is on the outside like this. This is the wing, so we draw it a bit like that, so as you can see. So he's flying around this way. Now his head's is up here, is in this direction. So he's going around this way in his plane. His head's up this way. That's okay, you're thinking? Yeah, you can do that. He gets to the top. His plane's this way and his head's up here. Then he comes down here, his plane's down this way, his tail's up that way, his wings are that way, and his head's here. Yeah, that's okay, you can dive down like that, yeah, no problem. Now, a bit later on though, see the problem here? How's he going to start getting out of this dive? And then he's like upside down. It's getting difficult to draw, let alone think about it. Right, the aeroplane's like that. His head's there, and his head's going up that way towards the ground. What's he going to be thinking when he gets here? Right, I went around like this. I went down, down, now I'm upside down. How am I going to pull out of this dive? How am I going to pull out of this dive now? Because I've got to do loop-the-loop, yeah? Not crash into the ground. I've got to go back up and I want to do it again. So he's going to start climbing now, upside down, and we're not talking about one of these trick planes or something that can flip their wings over or anything. We're talking about everyday aircraft and military aircraft and stuff. That are, you know, so, okay, what are we going to do? Oh, the guys on the ground go, oh, we know, the ball always saves it. So we put a golf ball in the middle of this thing here, put a little golf ball, right? Now he can go around it, can't he? That way around, yeah? Do you think? No, I don't. So what about, oh, I tell you what they say, you know, we'll throw a cricket ball into the centre of this loop-the-loop thing. Now he can go around the ball. That'll save the pilot from coming down out of this dive and he'd be able to go back up again and show us how great it is. Is that going to save him? Is that going to save this kind of a dive? What? So, well, that didn't work. They tried that, and I told them they got they had a cannon, and they fired it, big ball up here, and it was such a big mass like that. They thought, I'll fix it, like, you know. Because what we need is more mass, they thought, you know. This pilot's in danger, you've got to save him somehow. As long as we put some mass in the middle of there, he can fly around like that. Did that save him? What do you reckon? You answer that. Because I don't think that would save him myself. And we're talking a big, it's okay, we get a bigger cannon and make a bigger one. This is all one big cannonball, right? Is that going to save him? Of course not. But how big do we have to make this ball then? As big as the Earth, as big as the globe. Okay, so now this is the globe. We make it a bit bigger, tidy off the edges here. Now I put the globe in the middle. Now he's flying around like this. But it's the same airspace. Now the atmosphere goes up according to the science, the non-science, the fake science, whatever. They change their story and the atmosphere goes all the way up, way past the moon. They didn't need those spacesuits after all, you see, whatever. So, I mean, it's the same airspace, but he put a globe in the side. Same airspace all the way to the moon. And he's flying around like this. How's he going to come out of this dive? Starts off at the top of the world. Comes around. He's upside down. He's got to climb back up. You know, into this massive loop-the-loop thing. It's no wonder nobody has ever flown in that direction. We've only ever flown this way around. And there you go. I rest my case, Your Honour. I do have to explain these things. Let's put some more bit of colour in here, is it? That'll do. What about that? Because I know it's got to be round. See, if it's not round, they won't see it as the Earth. And if you drawed it oval, they wouldn't see that either. You know, because it's supposed to be oval shaped. You know, and no blatant swell, so they make it nice and round. But they won't understand. You know, they won't see it. Well, that's not a globe. That's the scribble, that is. Therefore, you're wrong. The Earth isn't flat. It's a globe.